Okay, here we are with our third installment in the linear equations group of videos. This one is about linear equations in general form, which you might have also heard called intercept form. And these equations look like ax plus by equals c, where a, b, and c are integers. Now it turns out this is a pretty helpful form to have an equation in because it's really easy to find both the x and y intercepts of lines in this form, and that makes it really easy to graph because those are 2 points and that's what it takes to graph a line. So we'll start out by looking at an example of how to graph one of these things. So we will start by taking a look at graphing this example 3x minus 4y equals 12. And as I mentioned, some people call this intercept form because it's really easy to find x and y intercepts if we remember what they mean. Now, an x-intercept means someplace where we hit the x-axis right here, and along there the y value is 0. So this will be our x-intercept. And our y-intercept likewise is where we hit the y-axis, and we hit the y-axis where x is 0. So these are the things we know, and we can use them to help us deal with this equation. So we will begin by solving for the x-intercept of this equation, which we'll find by plugging a 0 in for y and solving for x. And so what we can do is we can actually just cover up that y, because negative 4y, well, when y is 0, that's 0, and that just goes away. This is why we called it the cover-up method in Algebra 1. And we're left with the equation 3x is equal to 12y, so we should pretty quickly see that x is equal to 4. Similarly, we will look at the y-intercept, and we know for the y-intercept the x value is equal to 0. So we'll plug that 0 in for x in our equation, and this time we're covering up the x's, because 3 times 0 is 0, and that ceases to matter. Now we have negative 4y equals 12, which means that x is equal to negative 3. And we've now found both of our intercepts, and I can plot them on the graph. So I've got one point that is 4, 0 right here, and I've got another point that's 0, negative 3 right here. And this would be much better if I had a ruler, which you will have when you're doing this graph, but I'll connect those 2 points, and there I've got my line. And we'll do one more example like this, and I'll just remove this here so we remember the equation we were dealing with is 3x minus 4y equals 12. And additionally, we could put this equation into slope-intercept form and check that we do in fact get a y-intercept of negative 3 and a slope of 3/4. So here we'll work with the equation negative 4x plus 5y is equal to 10. And we'll remember that our y-intercept has a 0 for x, so this will be my y-int. And my x-intercept has a 0 for y. And I'll use that to do the cover-up method to determine the value of the other coordinate in these intercepts. So I'll start with the y-intercept, where I know that x is 0, so I can cover that right up. And I end up with 5y equals 10, which means that y is equal to 2. And for the x-intercept, I'll say, okay, I know that y is equal to 0, so I'll cover up those y's. Now I end up with negative 4x equals 10. This one's not quite as nice. I end up with x equals negative 5/2. But I can still work with that. So I can plot my points here. I've got 0, 2 for y, and I've got negative 5/2. That's negative 2.50 for x. And that's good enough for me to plot a line right here. But this does bring up an important point, that when you're using an equation in general form, and these integers, which we called a and b on the first screen, don't evenly divide the third integer c, it's not as easy to draw a nice graph, and you might be better served by converting this equation to an equation in slope-intercept form. Now, what many people find by far the most difficult part of dealing with general form is how do we take an equation in another form like point-slope or slope-intercept and convert it to an equation in general form. Now, some of these examples are quite straightforward. For example, this one. I remember that the form I want looks like ax plus by equals c. And I'd also be willing to accept by plus ax equals c. I don't really care which one of those comes first. And for this example, I can see that if I just subtract 2x from each side, I can pretty easily get negative 2x plus y equals 5. And there we are in the proper form. But the examples do get much more challenging. And it really is the fact that a, b, and c all need to be integers that tend to give people trouble here. But really what we need to do is just clear denominators in this equation. So I look at this and say, okay, I've got a denominator of 3, I've got a denominator of 2. If I were to add fractions with denominators of 3 and 2, I would need a common denominator of 6. And going back to what we did in class a couple days ago, we know that we can multiply both sides of an equation by anything we want to. I'm going to choose to multiply by what would be that common denominator of 6, and let's see what happens. I'll get that 6y equals, well, that's going to be 24 thirds x minus 6 halves. And I can go ahead and deal with these fractions, and I actually get that 6y equals 8x minus 3. And now just by subtracting 8x from each side, I get negative 8x plus 6y equals negative 3. And here we are in general form. So your general strategy here should be to clear denominators. Figure out what that least common denominator would be if you were to add the fractions that show up in your equation, and multiply both sides of the equation by that. You will no longer have fractions that you need to deal with. And let's take a look at one or two more complicated examples of this. So this time let's deal with this equation here that is in point-slope form. And we look at the two fractions we've got to deal with. We've got denominators of thirds and sevenths. So the least common denominator we would have would be 20 firsts. And so we're going to go ahead and multiply both sides of this equation by 21. We'll get 21y plus, oh, what will we have here? 42 thirds is equal to 84 sevenths times x plus 3. Now, a lot of people make a mistake here where they try to distribute the 21 to here and to here. You don't need to distribute multiplication over multiplication, right? Because the 4 sevenths gets multiplied by the x plus 3. We only need to multiply once into there. If you're at all confused about that, please see me because this is really important and it's a mistake that keeps coming up. So we can go ahead and deal with these fractions. We still have our 21y. This is going to be plus 14 is equal to 12 times x plus 3. Now I'm going to need to go ahead and distribute on the right hand side. 21y plus 14 is equal to 12x plus 36. I'll go ahead and subtract the 14. I get 21y equals 12x plus 22, and I can subtract my 12x. Negative 12x plus 21y is equal to 22. Now, as one additional note, as you're going through these problems, if you feel like you can skip this step right here by cross-canceling and immediately get to this step right here, that's fine with me and I might even encourage it. Now I suppose that's really all we have for today, so I'll go ahead and give you a few problems to prepare for class. So for the first two problems, please graph, and for the final problem, you're given an equation in point-slope form. Please go ahead and convert that to general form, remembering to clear your fractions to start. Thanks, and I'll see you tomorrow.